Hi and welcome to the On Maths GCSE Maths prediction for the OCR Paper 2 Higher Tier 2018 paper. Enjoy! Hi, I'm Chris Gilpin from On Maths. Now, what we do for this prediction is we take off all of the questions that came up in the paper 1 and we look at the remaining topics and see how often they've come up before, both on the new GCSEs and on the old GCSEs, and we make a prediction. Now, like I said on the paper 1 prediction, this is only used as part of your revision and not the sole purpose of your revision. So don't just look at this and leave it at that. However, as you might have seen with the paper 1 questions, quite a few came up across the different exam boards. But our predictions get more and more accurate as we go on, because obviously we now have seen the paper 1, so you can make predictions for the paper 2. All of our questions, all the questions you're going to see on this paper, you can do online on our website, onmaths.com. And if you go onto the website for free, you can either not sign up and just do the paper, and that's absolutely fine, or you can sign up and it will save your scores so you can try it multiple times, see if you can improve the scores. The onmaths.com also has topic busters, so you can practice every single topic. It also has demon questions for the harder style questions, and they're short little exams. They're only, I think, 20 marks, but they are just the toughest ones. And there's a whole load more things on the site. A new thing we're about to launch, so probably by the time you've seen this video, we have launched it, is the Revisionator. Now, the Revisionator is only skills-based questions, so no difficult questions. We leave that for the demon questions. But what we've managed to do is take off all the topics that have previously come up and allow you just to revise a random selection of skills-based questions that might come up. So if you use the Revisionator, it will allow you just to focus on the topics that you need to focus on for the exam. So we're really excited to launch that. If you're watching this as soon as it comes out, it might not be launched yet, but hopefully it will be launched next week. So really looking forward to that. If you've got any questions or comments, please leave them in the comments tab below. If you like this video, please click like. And if you want to see more videos from us, especially the paper 3 prediction, please click subscribe. I hope you enjoy. Okay, so we're asked to simplify the ratio. I'm just going to write it again, just to make it a bit bigger. So the first things we can do straight away is divide both sides by 10. So that'll be 30 to 55. Now any number that ends in a 5 or 0 is divisible by 5. So 6 times 5 is 30. And 11 times 5 is 55. 6 and 11, well, 11 is a prime number, so unless 6 is in the 11 times table, that is us finished. The rule to remember when you're dividing fractions is KFC. Keep the first fraction the same, flip the second fraction, and change the divide to a times. So I'm going to rewrite that. I'm going to keep the first fraction. I'm going to flip the second fraction, and I'm going to change the divide to a times. And then when you're timesing fractions, you times the top, so 1 times 7, and times the bottom, so 11 times 2. So it's 7 over 22. Okay, so for this question, we've basically got the mean of the numbers. We know what 3 of them are, but we don't know what the 4th one is, because the numbers rubbed off. Okay, so first thing for this question is think about how you would work out the mean. You'd work out the mean by adding these numbers together and then getting the answer and dividing by the amount of numbers we've got, which is 4. And we know that equals 12. So if I put an algebra letter in, so let's call it x, then I can write that down. So 9 plus 6 plus 15 plus x, which is our unknown, divided by 4 equals 12. Okay. Now, if I put my lines down and just try and solve it, first thing to do is I'm going to times both sides by 4 to get rid of that divide by 4. And I'm going to add these numbers together because we know what the answer to this is. So 15 plus 6 is 21, 21 plus 9 is 30. So 30 plus x, and we've got rid of the divide by 4 because we've times it by 4, equals, and then 12 times 4, which is 48. Okay, next thing to do is take away that 30. So we've got x equals 18. So I know the answer is 18, but I can check that, just to check whether I've got it right. So 9 plus 6 plus 15 plus 18 is going to be 48. 48 divided by the amount of numbers, which is 4. So 48 divided by 4 is 12. So that's my answer. Now, you could have done that through just trying different numbers out, but imagine in the exam, maybe the numbers are going to be a lot bigger. So this method is probably the quickest, but there are other methods, other ways of doing it. Whenever answering questions involving ratios, always just double check that you read the question, because here it might look like the total is £35, but if you read the question it says Adele and Bert received £35. Now, to do this question, we've got to first of all work out how much Adele and Bert are getting in the ratio, how many parts. So Adele gets 3 parts and Bert gets 2 parts. So A and B parts equals 3 for Adele and 2 for Bert. So that's 5 parts in total that they get. Now it says they receive £35, so we need to work out what 1 part is worth. So to find out what 1 part is worth, we do the £35 that theirs is worth, and we divide it by 5 because they have 5 parts in that ratio. 35 divided by 5 is 7. So 1 part is worth £7. Now Chris has 6 parts, so Chris, we're doing now, he has 6 parts. So we do 6 times the £7 that each of his parts are worth, so it's going to be £42. And it's really easy to make mistakes with ratios questions by not reading the question, so just make sure you double check that you understand what the question's asking. Question A seems like a really complicated question, but it really isn't. If you think about what you know about a rectangle, you know that opposite sides of a rectangle are equal. So if you just write down x plus 1 is the same as 12, and then solve it. So what we're going to do is we're going to take away 1 both sides. Then x equals 11. So we know that x is 11. Let's check that out. It says here x minus 1. Well, what is 11 take away 1? Well, it's 10. And that is the same as that. So we know that x equals 11. And that's it. Question B. Have a think about what you know. You know that all angles in a triangle add up to 180. So we know that if we add y, 2y, and 3y together, it's going to equal 180 degrees. So again, let's just get our lines down so that we can solve it. So 1y plus 2y plus 3y, well, that gives us 6y in total. And then what we need to do is get rid of that times 6 there by dividing 6 both sides. So y equals 180 divided by 6. Well, I know 18 divided by 6 is 3, so I know that's going to be 30. Okay, so in this question we're on a school trip, and it's best to break this question down into bits we need to work out. So it says 4 buses each carry 105 students. So the first thing I need to work out is how many students there are in total. It says 35% of the students are bringing their own lunch, so we don't need to worry too much about those students. A seventh of the students are buying lunch when they get to the theme park, and the question just basically says how many have not made plans for lunch. Okay, so find out how many students have not made plans for lunch. So they're not bringing their own lunch and they're not planning to buy lunch there. So let's do the first thing first, and let's work out the total students, total amount of students. and show the examiner what you're working out each time. So we're going to do 105 times by 4. You can do that any method you want, but it's going to be 100 times 4 is 400, 5 times 4 is 20, so it's going to be 420 students. So we've got 420 students in total. So next we need to work out how many are bringing their own lunch. So bringing lunch. Okay, so to do this, we're going to work out 10% first, which is going to be 42. Because if 100% is 420, that's how many students we have. 10% is you just divide it by 10. And next we can work out 5%, which is going to be half of that, so it's just going to be 21. Next we need to work out 30% because we need 35%. And all we do is times the 10% by 3. And again, I could do a bit of working out for this. So 42 times by 3. And you can use any method you want. A lot of you probably prefer doing the grid, which is absolutely fine. So 40 and 2 and 3. Obviously, if it's on the calculator paper, you can obviously just use a calculator. But either way, you get 126. So it's going to be 126. Now 35 would be these two added together. So it's going to be these two added together, because 5 plus 30 is 35. So 35% is going to be, and I can do a bit of working out here, so 126 plus 21, or the other way around, 741, so 147. Okay, so 147 students are bringing lunch. Next, so buying at park. So students who are buying at the theme park, it says a seventh of the students. So to find a seventh, all we do is we get the amount of students, which is 420, and we just divide it by 7. And again, you can do this any way you feel comfortable doing, although this is a bit easy because 42 divided by 7 we know is going to be 6. So 7s into 4 don't go, so carry that on. 7s into 42 are 6, 7s into 0 is 0. So it's going to be 60. So students left. So we're going to do the amount of students, which is 420, take away the people who are bringing lunch, plus the people who are buying it in the park. So we need to work out what that is. So it's 147 plus 60. So 7 plus 0 is 7. That's going to be 10. And so that's going to be 207. And finally we need to work that out. So 420 take away 207. So you can't do 0 take away 7, so we nick 1 there. 10 take away 7 is 3. We need to nick 1 there as well. So 11 take away 0. Oh no, I don't need to nick 1 there, do I? So we've just got 1, so that's 1. 4 take away 2 is 2. So the answer is 213. Now it's really important that you set your work out really logically. Any working out you do, try and keep it near where you've done done the calculation, written the calculation down. So I'd probably put this down here if I had like a piece of paper in front of me. Obviously I've moved these around slightly just to make them a bit clearer, so I'm not constantly scrolling. The headings are really helpful. So as an examiner, if you've headed all of your working out, it's really easy to spot what you've done and give you credit for it. So just make sure you set out your working out neatly and logically. So we're told 1 kilogram of cheese costs £7.70. How much would 600 grams cost? Well, first of all, I'm going to have weight, mass, and price. And I'm just going to sort of split them down the middle. So the weight, well, 1 kilogram is not going to help us because this one's in grams. So I'm going to convert that to grams. So it's 1,000 grams. And I'm going to convert this into pence. So 770 pence. Okay, so I need to get to 600 grams. And so first of all, if I've got a calculator, I can do this a lot easier. But without a calculator, let's try. Well, I can first of all divide this by 10 to get it so that it's 100. So that's 100 grams, and that would be 77. And then what I can do is I can times these by 6 to get 600. Okay, so if you've got a calculator you can just type it in, but let's assume that you don't for this question. So we've got 77 times 6. 6 times 7 is 42, add a 0, 6 times 7 is 42, add them together. Probably don't need to do this, but anyway, I'll do it anyway. 264. So it's 462 pence, but in pounds it would be £4.62. Last thing, just check it makes sense. Well, we've got just over half, so therefore the price is just over half. So it looks good to me. Okay, so for this question, it's really common to take the wrong approach with this. For instance, the biggest wrong answer for this is to try and get from 6 to 4. So we can divide it by 3 and then double it. So we're going to divide the days by 3, which is 4, and then double that. So the most common wrong answer is 8 days. And I understand why people put that answer down, but think about it logically. 6 people take 12 days. 4 people, which is less, so you imagine there's a task and you've got 6 people and then you've got 4 people, okay? You'd expect it to take longer. So if it took 12 days before, it wouldn't suddenly take 8 days. Otherwise, why would people employ more people? Why would a foreman employ more builders if less is better? So we know that that's the wrong answer. How do we work out the correct answer? Well, there's a really simple way of thinking about this. And it's to think about this thing I'm just making up now called people days. So every job has an amount of people days. Okay, and to work out the amount of people days for this, you get the amount of people, which is 6, and you times it by the amount of days it takes, which is 12. So 6 times 12 is 72. So it's going to take 72 people days. So for instance, if we had one person, which we could have, it will take that one person 72 days. If we had 2 people, it would take them half of the 72. So it says we've got 4 people. So what we do is you get the amount of people days, which is 72. But we don't have one person anymore. We've got 4 people, so we're going to divide it by 4. Now an easy way to divide something by 4 is to halve it, then halve it again. So 72 divided by 2 is 36, then halve it again is 18. So the answer is 18 days. Now, let's have a look and see if that's realistic. Well, it took 6 people 12 days, so 4 people, which is less, will take longer. So instead of 12 days, 18 days. Now, there is an assumption we've made, and that's that all the people work or paint at the same rate. Now, it could be that the 6 people we originally had were kind of lazy, not very good at painting, had other distractions. And the 4 people we had are amazing people at painting. And actually, maybe they did take less time. Or it could be that it rained when the 6 people tried to do it, and it didn't rain when the 4 people tried to do it. Don't get too creative with your explanations. They're looking for just some understanding that this is what we call in maths a model for working stuff out, and it doesn't always work because whenever you're working with people are different. We're all different. We've each got our individual differences. So anything that says that the people might not work at the same rate, absolutely fine, we'll get you the mark. Now this question looks a bit complicated, but the easiest or best way of approaching it is kind of put the question to the back of your mind and just try and write down all of the angles and the reasons for them that you can. So the first one I'm going to label is this one. I know it's a right angle because angles on a straight line equal 180. So therefore I can work out this one here. Because there's a triangle there, one with 26 degrees, one with 90 degrees, we can take them away from 180, and that will give me, so let's do that now, and that will give me 64. And it's important to write down the reasons. So angle BCA equals 180 take away 90 plus 26 equals 64 degrees. Angles in triangle equal 180. And I'd write it in words for the actual exam. Okay, next thing I realise is that the x here is equal to the angle here. So this is also x. So angle BAC equals x. And the reason for that is z angles, although you have to use the right word, just alternate angles. Okay, the next bit, if you have only used the diagram and not read the question, you're going to have real problems because you can't answer the next bit without reading the question. This bit here in the question is critical, the fact that AB is the same as AC. So that length there and that length there are equal. Now something we do know about isosceles triangles, which this is that bottom two angles are equal. They are the same. Therefore, the next bit I can write down is angle ABC is going to equal 64 degrees as well. ISOS, because it's an isosceles triangle. Now we've got all of the angles, so we know that x plus the 64 at the bottom plus the 64 on the right hand side, so 64 on the left hand side plus 64 on the right hand side, we've got the 64 there from the previous question, equal 180 degrees, because again angles in a triangle equal 180 degrees. Equal 180 degrees. So we can finish it off by solving it. So I put my lines down. So we add 64 and 64 together, which would be 128. So x plus 128 equals 180. And we're going to take away the 128 from both sides. So we do 180 take away 128, which is 52. Now this isn't the only way of doing this. There are other methods. You could have tried to find this angle here. And those of you who are really good with algebra can try and understand why x will always be twice the angle here. So that's a little bit more of a challenge for you if you want to do that. So when conducting a survey, you've got to make sure that you are looking into a few areas. The first area is to make sure that your questionnaire is fair, that it's not swaying the person's opinion with leading questions. The second thing you need to be careful of is that your sample is what we call representative. It means that everyone from all different areas have a view. So for instance, if you were looking at investigating the school canteen and you only picked people who used the school canteen, then it's probably going to be swayed towards how wonderful the canteen is, rather than the people who don't go to the canteen, who probably don't go because they don't like the canteen or because they bring packed lunch. The other thing that you need to look for, and there's quite a long list, but the other main thing you need to look for is that your sample is big enough. If it's too small, then it can't possibly be representative. So when it says select 5 names, 5 people is not enough for a proper survey. So my answer to this is step 3, and I would say sample is too small. Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70, take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So it's 900, that's 21 with a 0. So 900 plus 21, 210 even, 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for one child, so that's one child. So if I want 2 children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit, and let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. So inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half, because that's not a whole number. Now, x says here x is greater than -7 and is less than or equal to 3. So when it asks you to write down all the numbers that's true for, well, let's have a think. Well, if it's if it's greater than -7, then it can't be -7. It can't be equal to it. So it's going to be -6, -5, -4, -3, -2, -1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the -7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times minus 5 is minus 25. Now, you could have divided both sides by 5, and that would have been fine. Next step is to get rid of this minus 25. And you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that minus 25. So we're left with 15x on this side. And 35 plus 25 will be, well, 5 plus 35 is 40. 40 plus 20 is 60. Now, to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now, be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. Okay, this question looks quite confusing because it says the weight of the sack is 19 kilograms, but then it asks you for the smallest and largest possible weight that it could be. So it seems quite confusing at first until we realise that it is rounded to the nearest kilogram. So the first diagram I draw out is just a line, and I put 19 in the middle. And I think to myself, right, what was the next one down that it could have been? If it wasn't 19, if it was less, what's the next one down it could have been? Well, the next one down would be 18. And then I think, well, what's the next one up it could be? Well, it could have been 20. It's not 18 or 20, it's 19. And then I think, well, what's the cutoff point between 18 and 19? So I draw a line down here, and the cutoff point would have been 18.5. So if it was 18.4, it would have been rounded to 18, but 18.5 or more, it's rounded to 19. And I do the same on the other side. So I draw a line between here and here, and this time I think, right, what's the cutoff point for this one? Well, that's 19.5. Now, this second one's a little bit more complicated because you might think, oh, actually 19.5 would round to 20. So it's 19.49 recurring. Yes, you would actually be true. Unfortunately, 19.49 recurring is actually the same as 19.5. So for our smallest possible weight, we put 18.5. And for the maximum possible weight, we can actually put 19.5, even though we know that would have rounded to 20. Now, this works because it's a continuous scale. If you were doing an amount of counters, say if it was 19 counters, or I don't know, 190 counters to the nearest 10, then the lowest one would be 185, that would be fine. But the highest it could have been before it was rounded to the nearest 10 would be 194, because you can't get like a 0.1 of a counter. So just be wary of that if you're working in discrete calculations, so things that can't be 0.00001 or something, then you do 4 at the end of it for the maximum. But if you're working with heights, weights, things like that, then 19.5 for this one is absolutely correct. So to answer this question, we need to be really familiar with the formula y equals mx plus c. Now, y and x will constantly change, but m is what we call the gradient, and c, or plus c, is what we call the y-intercept. Okay, so we need to understand how to use that formula for this question. Now, it already tells us that the gradient of the line is 3, so we can fill that in. So it's y equals 3x plus c. Nice and easy. The only thing we don't have is the y-intercept. Now, the way of getting the y-intercept is substituting in the values we know. We know when x is 3, y is 17. So what I'm going to do is just put in the values, put in the values of 3 for x and 17 for y. So it's going to be 17 equals 3 times 3 plus c, and I'm going to put my lines in so that I can solve it. So that's 17 equals 9 plus c, and we're going to take away 9 from both sides. So it's going to be 8 equals c, or just c equals 8. So looking back at this formula we had earlier, we had m but we didn't have c. Well, we now have c, which is 8. So it's y equals 3x plus 8. And you can check that by putting in the values of 3 as x and see whether you get 17. 3 times 3 is 9, 9 plus 8 is 17. Okay, so the most important word in this question is this word here. As soon as you're asked to estimate something, it means you're going to round all of the numbers to normally one significant figure. There are a few exceptions like square roots where you round it to the nearest square number. So we're given this formula here, and we're given 4/3 times pi times r cubed. So what I need to do is write down what I'm rounding everything to first. So that pi, we know pi is 3.141 blah 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 blah. So I'm going to round that to 3, and I've done a mistake there. I've said equals, and what I should write is a kind of little squiggle equals, meaning roughly. Okay, and r is roughly, well, it says radius is 3.22, so that's roughly 3 as well. So we're going to do 4/3 times pi, which we're saying is roughly 3, times 3 cubed. So when I do that, now if you notice, the divide, the over 3 there and through one of the 3's there will cancel. So we're going to do 4 times 3 cubed is 3 times 3, which is 9, times 3 is 27. And so we're going to do 4 times 27. So 4 times 27, which would be 4 times 7 plus 4 times 20, which is 108. Now there's a few things to notice. I could have rounded the 4/3 just to 1 and then just done 27 times 3. That would give me a slightly different answer, but that's still technically correct. You've just rounded the 4/3 to 1. They are quite liberal with what you round with these types of question. Pi is a nice easy one to round because that will always, for an estimation question, always round to 3. Now it says, is it an underestimate or overestimate? Well, pi was rounded up, so was rounded down. And the radius was rounded, well, it was 3.22 and we've rounded it down. So if you think about it, it's two numbers that are too small multiplied together, and one of those numbers is cubed, so it's going to be an underestimate. Now be careful, if there's a division in the question, you'll end up with a situation that it's going to be the opposite for the bottom number. So for instance, a over b, if we rounded b down, that would actually end up with a bigger number. So just be careful with division and subtraction with these, but when you're adding or multiplying, if you're rounding them both down, it will be an underestimate. Okay, so this looks like a quite simple question, however it's a little bit more complicated than it looks. It says that the sum of 3 consecutive numbers is divisible by 3, and we've got to prove it, so the working out is everything. So I'm going to name my first number x, okay, because we don't know what it is, it could be anything. But the next number will be x, same as the number before, but 1 added to it. And the next number after that is going to be the same as the first number, but 2 added to it. And it says the sum, so what we're going to do is we're going to add these 3 numbers together. So x plus x plus x is 3x, 1 plus 2 is 3. Now, this hasn't proved that they're divisible by 3 yet. All I need to do now is factorise this out. So I'm going to divide each of those by 3. Now that now is proof that they are divisible by 3, because if you times any number by 3, it will be in the 3 times table. So my proof is this bit here, and I could write a sentence saying any number that I times by 3 will be divisible by 3. And on the site, that's all you need to put in. Okay, so boxplot question. Now, it might be tempting to think that the information here is all you need to plot on the boxplot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other 2 that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is at 22. There we go, and that's our box plot. So that's question 1 done. Or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students. So I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5, that doesn't make much sense. So on this question I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down, because you've shown that it's 17.5, well you can't get half a student, so let's go for 17, or let's go for 18. Now both these questions just rely on you remembering the rules. The most common wrong answer for A is 50. Anything to the power of a half is a square root. So the square root of 100 is 10. So the answer is 10. Now you could have had plus or minus 10, but for this question they normally aren't that fussed about having the negative version. Anything to the power of negative, again, most common wrong answer is something like minus 16 or something like that. Negative just means you flip it. So the number 4 on its own is just 4 over 1 as a fraction. So if we're flipping that, it becomes 1 over 4. But because it was minus 2, that 2 stays with the 4, so it's still 1 over 4 squared. 4 squared is 16, so it's just 1 over 16. Now it could have the word evaluate in either of these questions. Okay, this is a basic circle theorem question. And the only thing we need to know is which circle theorem this is, where it's a quadrilateral with each of the points on the circle, so it's cyclic quadrilateral, And the circle theorem says that opposite angles in a cyclic quadrilateral add up to 180 degrees. So we just do 180 minus 65, which equals, I think, 115 degrees. So it'd be 115. And the response that they need is simply opposite angles in a cyclic quadrilateral. So opposite angles in a cyclic quadrilateral, I should write the whole thing. Opposite angles in cyclic quadrilateral add to 180 degrees. In most exams, they're just looking for cyclic quadrilateral as a reason, and normally it's you'd write down it in just the first part of the question. It will say work out what x is and give reasons for your answer, and you just put in brackets cyclic quadrilateral. But it's always best to write too much than too little. So cumulative frequency is just a running total. So the first cumulative frequency is just going to be 8, because that's all the frequencies we've got so far. Then I'm going to add on the 4 to the 8 to get 12. Then I'm going to add the 15 onto the 12 to get 27. Then I'm going to add the 22 onto the 27 to get 49. Then I'm going to add the 11 on to get 60. Now, a way of checking this sometimes is that the last one should be the total amount of whatever it is. Well, it tells us there's 60 people in the question, so we should end with 60. Now we need to plot that onto our graph, and we're going to do that. So the first one is, so what have we got? Okay, now the only time you'll look on the left hand side is to see where the graph starts. So we know it's going to start at 0. All the other plots are going to be from the right hand side. Now, students get this and frequency polygons mixed up. Frequency polygons are from the midpoints, cumulative frequency are from the maximum points. So we've got 5, 8, so it's going to be 5 across and 8 up, which is slightly higher than this. We've got 10, 12, so 10 across and 12 up, just about there. Then we've got 15, 27, so 15 and then 27. Then we've got 20, 49, so 20, 49. And the last one is 25, 60. Now that's not completed yet. What you need to do is draw a curve going through that. Now most exams don't mind you joining them up with straight lines, but on a few of the exams you must use a curve. Now the important thing with the curve is it goes through all the points. So let's try my best here. I'm going to do it in different colours so it shows up. So one continuous curve going through all the points. Now mine's not great, but that's probably good enough to get the full marks. I could probably had it a bit straighter. Back in the old days you used to have bendy rulers as part of your equipment, but you don't have them so much anymore. Okay, so question C, use your graph to find an estimate for the median age. Now the first thing you've got to figure out is what your graph goes up to. Now don't just rely on what the top of this bit is, it's where your graph goes up to. Now mine happens to be the same, but sometimes your graph might go up to 70, the scale might go up to 70, but your actual graph might only go up to 60. And to find the median, you just halve the 60, but 30 is not the median, 30 is how we find the median. To get the median, we need to draw a line across from 30. So we're going to draw a line across until it hits our line, and then we're going to draw a line down from where it hits it. Now mine looks roughly, I would say about maybe 16. I think I'm going to go for 16 for mine. Now, everyone draws the lines a little bit differently, so there's always a little bit of leeway in the mark scheme. What I recommend you do is that you draw the working out onto your cumulative frequency graph so they can see where you got the number from. Okay, last question says, what age were 25% of the people questioned older than? And that's important. Where were 25% of the people older than? Now this is actually asking us what the upper quartile is. So we need to work out the upper quartile, and to do that, easy way of doing the upper quartile is you work out the lower quartile, work out which number you have to go across from. You do that by halving the number used for the median, so it'd be 15. And then you add the 30 and the 15 together. That's going to be 45. And then we're going to draw a line across from 45, just like we did when we found the median, and down. And I would say that's 16, 17, 18. That's, to me, about 19. So I would say that 25% of the people were older than 19. Well, let's see if that makes sense. Well, our people were aged between 0 and 25, and so that would kind of just make sense. You just look at the numbers and you go, well, that kind of tallies. Now there are two things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, or whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here. It could be 5x plus 10. That's absolutely fine. Still the right answer. Over x plus 3. Now there's a couple of ways of doing this question. We're asked to complete the table and then complete the histogram. You can do this by counting squares, but I'm just going to use the formula for this. And the formula, choose the right one. The formula has frequency at the top and frequency density and class width at the bottom. And it works the same way as most, or speed, distance, time, and all of those ones. So we know that class width, let's work out the class widths for these. That's going to be 40, that's going to be 40, that's going to be 20. And I'm just looking at the distances between the 80 and the 100, so I'm doing 100 take away 80. So the next one's going to be 40, and the last one is going to be 60. Okay, now I know that I do the frequency divided by the class width to work out the frequency density. So I'm going to do 44 divided by 40. So I'm going to divide that by the class width, which gives me 1.1. Now if I go to my diagram and label that as 1.1, because frequency density is on that axis, on the y-axis, then if I look down, well, I notice that that's going to be 1.0, 0.8, 0.6, 0.4, 0.2 and 0. So it works perfectly, and then obviously 1.2 at the top. So now I know my frequency densities, I can actually work out what the next frequencies are. So the next one has a frequency density of 0.6. So I'm going to times that by 0.6, because this is our frequency densities. Times that by 0.6, so I'm going to do 40 times 0.6, which is 24. The next one has a frequency density of 1.2, looking at the graph, or looking at the histogram, so 1.2. So I do 20 times 1.2, which is 24 as well. Okay, this time I've got to work backwards. So I've given the frequency and I've given the class width. So I need to divide them across. So divide that by 40 and divide that by 60 to work out the frequency densities. So 24 divided by 40 is going to be 0.6, and 36 divided by 60 is going to be 0.6 as well. Well, that's convenient. So they're both 0.6. So the first bar is going to be at 100 to 140, and it's going to be 0.6. So 140 is going to be there. And then the next bar is going to be 140 to 200. So it's a slightly longer bar there. And I'm just putting these off center so you can see them a little bit better. Now you don't need to shade these bars in, just draw them with a pencil and a ruler, and then that's it. Now this is a question about composite functions, and I'm going to start this question off by just answering this question. What is f bracket 4? Now this equation here, up until this level, that used to be y equals 4x, and the question we have here would be, what is y when x equals 4? It's the same question, it's just a different way of writing it. So all you need to do for f brackets 4 is feed in 4 as x. So that's going to be 4 times 4, which is 16. Okay, same answer as this, and it's the same question just written differently. And at this level you need to be comfortable with function notation rather than y equals. Okay, now I said I'd ignore the g. The g says, oh okay, when you're done with f, g wants to do it as well. So what I should be writing is this, and I still have to apply a g to all of this. Let's get rid of that. And so I still need to apply the g to the 16. So we've done the f, and the f we did first because it's closest to the brackets. So whichever one's closest to the brackets you do first. Okay, we've done the f. Now we need to do the g, and we just do exactly the same thing. So g of 16, we're going to feed 16 into the equation. Well, it says 7 plus 2x, so it's going to be 7 plus 2 times 16. Well, I know 2 times 16 is 32, and I know 32 plus 7 is going to be 39. 39, okay. And so therefore the answer is just 39. Okay, perfect. Right, the next one. This time it's important to notice that the f and g are the other way around. So it's g that we're going to be doing first and then f. Now the thing we're feeding in is x. Well, you can't feed in x as x. Well, you can. It's just going to remain as x. So let's focus on the g first. So we're going to do g of x first. And now g of x is just given to us in the question. It's this bit here. So it's going to be 7 plus 2x. Now f wants to then use that 7 plus 2x and feed it into the f of x equation. So f of x is 4 times x. We're feeding in the 7 plus 2x, so it's going to be 4 times 7 plus 2x. Then we can expand that a little bit. So 4 times 7 is 28, plus 4 times 2 is 8x. Okay. Now, there's an equation here which I've kind of ignored up until now, but we need to write it now. So it says that 28 plus 8x, which is the fg brackets x, equals 52. So let's sort that out, solve that. So the first thing I can do is take away 28 both sides. And if it's on the calculator paper, you might as well use a calculator to double check your answer. If it's not on the calculator paper, I think most of you will be able to work that out. It's 24. And then we want to divide the 8. So we get x equals, so it's x equals 3. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2. And you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2. So what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here, because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done. So we can cross that off. Okay, next one, we want to do the line x equals minus 1. Okay, so where does x equal minus 1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals minus 1. Okay, so where do we not want? Well, x is going to be greater than minus 1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, now the last one, I'm going to do the line y equals x plus 2. Now, there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. And 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R. Okay, so the first thing to do in this question is notice that we've got a bracket squared and another bracket squared. So the first thing to do is you need to write those brackets twice. If you don't do that, you end up squaring the 3 and squaring the root 2 and then thinking that you're going to get the right answer. Unfortunately, you can't get the right answer with just squaring the two of them because they are quadratics. So I'm going to write them out as two brackets because anything squared is itself times itself. Okay, now we're going to expand these. Now I'm not going to go into the methods of expanding quadratics, but we've got loads of videos on our channel and our website to help you with that. So use whatever method you are comfortable with, whether it's FOIL or smiley face or whatever you want. I'm going to put them into brackets though. So 3 times 3 is 9. Then we've got plus 3 root 2 plus 3 root 2, so plus 6 root 2. And then we've got root 2 times root 2, which is plus 2. Okay, so second one, 3 times 3 is 9. And we've got minus 3 root 2 minus 3 root 2, which is minus 6 root 2. And then we've got minus root 2 times minus root 2. 2 minuses make a plus, and root 2 times root 2 is root 2. Now, the reason I kept them in brackets is because this is really important. There's a minus 1 there, and it means we've got to multiply everything in the second bracket by minus 1. So the first bracket's unaffected, so we're just going to get rid of the brackets there. Don't need to worry about that. But the second bracket, I need to times everything by minus 1. So that first one is a minus 9. The second one is, well, minus times a minus is a positive 6 root 2. And then a minus times a positive is a minus, so minus 2. That means that we can cancel out the 9s there. We can cancel out the 2s there. And all we're really collecting here are the roots. So 6 root 2 plus 6 root 2 is 12 root 2. Now it says it wants it in the form a root b. So a is the number outside the surd, which is 12, and b is the number inside the surd, which is 2. Okay, so in this question we're given 5 times square root 125, and we're asked to make it in the form 5 to the power of something. So this bit here is kind of our objective. We've got to make this so it's just a single power of 5. Well, 5 at the moment, well, that's quite nice of them to give us a 5, but 5 is to the power of 1, and that's going to be maybe important later on. So 5 to the power of 1 is just 5 times. Now, I notice 125 is actually 5 cubed, so I'm going to rewrite that as 5 cubed. 5 times 5 is 25, times 5 is 125, so that might help us. I'm thinking, right, that square root I can rewrite as to the power of a half. So I'm going to get that 5 to the power of 3, and I'm going to put that to the power of a half. To the power of a half and square root are the same thing, and that's something you need to know about indices. Okay, now the second rule that I'll need is if I've got a number inside and a number outside of a bracket, which I do here, I times them. So that's going to be the same as 5 to the power of 1.5 or 3 over 2. Okay, or 1.5. I could just write it as 1.5. It doesn't matter. Okay, it's sometimes easier to do just a top-heavy fraction because obviously when you're writing powers, you're already writing small, and it gets a bit complicated otherwise. So it doesn't matter. And the other rule I'll need to know about indices is when you times them, you add the powers. So it's going to be 5 to the power of 2.5. and it says write your answer as a decimal. So it's 2.5 as a decimal, it's just 2.5. Okay, so for this question you need understanding of sine, cos and tan graphs. This one's about sine graph, and you just need to know what it looks like. So point A, I know that the maximum a sine or cos graph go to is 1, and sine graph reaches that at 90 degrees. So it's going to be 90 on our x-axis and 1 on our y-axis. At point B, I know it gets there to 0 at 180, because it's 360 in total, and it reaches that 0 point halfway. So it's going to be 180 across and 0 up. Now this is quite a tricky question really. This is about graphic transformations, and there's 3 parts of this, A, B and C, and we've got to figure out, well, what's looking different with this cos graph. Well, cos normally, if I just sketch one out, normally starts at 1, goes down to 0, goes down to -1, and then goes back up to 1. And it does that at 90 degrees, 180 degrees it reaches its minimum, 270, and then 360 goes back up to 1. So it's between 1 and -1. Okay, so what's different? Well, it's slightly higher up, it's more stretched out upwards, and it's compressed to the right. Okay, so let's have a look at B first. Now, the function within, or the number within a function will affect the stretching on the x-axis. So let's have a look. Well, it normally has kind of one circuit or one period between 0 and 360. On this one it has one here, it then does the whole thing again, and then it does the whole thing a third time. So the B is going to be 3 because it does it 3 times. Now it might seem a bit odd that it seems to be getting compressed the higher B is. So if B was 4, it would be even more compressed. It kind of works the opposite way around within the function, within the cos, because basically at the point here, which is going to be, I think, 120, if you think about it, you type in cos 120, and then before you type in, you type in 120, but before you type in the cos, you times it by 3. The cos will think you're at 360, so it will be going up to 1 again. Anyway, okay, so that's the first bit done. So B is 3. Now if it stretched out, say if cos looked like this, then it would be a half. So if you're only getting half a kind of full rotation, a full circuit, a full wave, whatever you want to call it, then it will be a half. Okay. The next 2 are quite easy because you can see on my diagram here we're between 1 and -1 normally, which is 2. Okay, and on this one between 3 and -1 we're now 4. So we've had to times it by 2 to kind of stretch it out. So we've had to times it by 2, so A is going to be 2. But you would think, well, hang on, if we times it by 2, then it should be between 2 and -2, but it's not. It's kind of moved up 1, and the reason for that is because we've added 1 onto it. So C is going to be 1 because it's just shifted 1 up. Not the easiest question in the world, however, with a bit of practice, you'll get there. This question could be a show that question where it gives you the decimal and the fraction, or it could just ask you to work it out. So it could turn up on either paper. So the first thing I'm going to do is just convert this. I'm just going to be investigating this first, and then I'll worry about the 0.0 later on. Okay, so way of doing this is get x equal to 0.8686 blah 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 recurring. Now we need to bring that 86 in front of the decimal point, so I'm going to times it by 100. So I'm going to work out 100x is 86.8686 blah blah blah. And then what you do is you just take away going downwards. The reason we do that you will see in a second. So 99x, because it's 100x take away x, which is 99x, and it's 86 point recurring pattern take away 0 point recurring pattern. The recurring patterns take away, so we're just left with 86. I'm then going to divide both sides by 99. So it's x equals 86 over 99. Now, I said I'd ignore the 0.0 bit. I'd ignore this bit earlier. Well, I can't ignore it anymore. So how do I get from 0.86 recurring to 0.086 recurring? Well, I'm just going to divide by 10. So what I want to do is I want to do 86 over 99 divided by 10. Now the way I can do that is just times the bottom of the fraction by 10, and that's the same as dividing it by 10. And we should write 0.086 recurring equals, to show the examiner that that's what we're doing. Okay, so we can cancel at this point. If you have a look, we can divide top and bottom by 2. So we're left with, I can show that I'm dividing by 2. So we're keeping the fraction the same. So that will be 43 over, and half of 900 is 450, half of 90 is 45, so it'd be 450 plus 45. And you don't need to show this working out, but I'm doing it just to show you. So it'd be 495. Now, I don't think there's another number that goes into 43 and 495, so I'm going to sort of leave it there. Normally when you're asked to simplify, or normally when the numbers are big, you won't be asked to simplify it, or there will be a very easy way of simplifying it.
Okay, so this doesn't seem like the easiest questions, because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple, because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x, because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x, because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that a hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder, wow, tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed, brilliant. So plus the cone, now what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next. Pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. There's both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2. Equals x over 50. So our answer is h equals x over 50.
This question might just ask you to rationalize the denominator. It might ask this question the form that's in, or it might ask you to show that that fraction is the same as another one, where you'll get marks for the working out. So to do this one, what rationalizing means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalizing means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top.
So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, positive times a negative is a negative. And any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5, 11 root 5 is going to be, well, if you think about it, you've got 11 of something, and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now the 3 doesn't go into 25, so we can't cancel it any further, so it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3, and the bottom number is 58.
Thank you very much for watching this video. Hopefully you found it useful. Don't forget you can go onto our website onmaths.com, which I'm sure the link will appear above me, to practice this paper and practice other papers as well. We've got all the previous year's predictions as well, which might be useful. And also we've got the new Revisionator coming out, so we're really excited. If you've enjoyed this video, please click like. If you want to see more from us, especially paper 3, please click subscribe. Thank you very much.